In this video, we'll state a few theorems of closed and periodic orbits, including the famous Poincare-Bendixson theorem. Theorem. Every periodic orbit contains at least one fixed point. So in the Lotka-Volterra model, remember, we had periodic orbits as the predator and prey species fluctuated. Those periodic orbits were around a fixed point. And this theorem says that's the only way we can have them. The next theorem requires a little preliminary material. We'll call a region forward invariant if any trajectory that starts in the region stays in the region forever. We saw a good example of this with the competition model of ecology. Neither animal species could get above its carrying capacity. And of course, neither animal species could be negative. So any initial condition that started in this box stayed in this box. It could go to the edge of the box, but it couldn't leave it. We call a set closed if it contains its boundary points. So, for example, if we're looking at the region x squared plus y squared is less than 1, that's not closed. because the boundary of the circle isn't included. But x squared plus y squared is less than or equal to 1 is closed because the boundary is included. And a region is bounded if, well, if it's bounded. So the first quadrant is not bounded because it goes off infinitely far in this direction. But something like a circle or a square is bounded. The Poincare-Bendixson theorem is for closed and bounded sets. And once you get to analysis, you'll see why that combination is so important. So, theorem. Let M be a closed, bounded, and forward invariant region in the plane. Then any trajectory is either 1, a fixed point, 2, a periodic orbit, or 3, converges to 1 of those things. So you can't see very complicated behavior. Trajectories that are stuck in this region settle down quickly. They converge to a fixed point or to some kind of closed orbit around a fixed point. In this video, we stated a few of the more major theorems for periodic orbits. It's interesting to ask whether the Poincare-Bendixson theorem can be generalized to three-dimensional space. The answer to that question is a resounding no, and this will provide our last object of study in this course.